Welcome to DTH channel and to the course Atomic and Nuclear Physics for BSc Physics third year students, 5th semester. In this course, the first lecture is about Introduction to Atom. Atom is the fundamental entity of matter. I am going to organize this lecture in the following way. Introduction about this lecture, history of atom, structure of an atom, brief about atom models, and summary of the discussions we are going to have. The term atom comes from the Greek word meaning indivisible, because it was once thought that atoms were the smallest thing in the universe and could not be divided. That's not the case today, because atom is not a fundamental entity today. Atom is made up of many subatomic particles. To today's understanding, protons, neutrons and electrons are the constituent of atoms, and these protons, neutrons and electrons are made up of quarks. Current particle physics research explains why these subatomic particles constitutes atom. But earlier, atom was the fundamental entity. The term atom was derived from the Greek term atomos. Greek philosopher coined this term. Then later this atom is thought made up of three particles named proton, neutron and electron, which are composed of even smaller particles such as quarks. According to current understanding by the CERN laboratory in Europe, which is pioneer in particle research, atom would have been created some 13.7 billion years ago. That's the explanation they are giving about atom. 13.7 billion years ago, Big Bang theory have started. According to this Big Bang theory, the universe have started some 13.7 billion years ago. This hot, dense new universe cooled to become a suitable one for quarks and electrons to form. This is the explanation that CERN research laboratory gives for the formation of electron and atom and other subatomic particles. Quarks came together to form protons and neutrons, and these particles combined into nuclei. This all took place within the few minutes of the existence of the universe. 13.7 billion years ago, universe was created. That universe exists for a few minutes that time. That within that few minutes itself, these atoms, these subatomic particles have created. And it took 380,000 years for the universe to cool enough to slow down the electrons, so that electron will become the part of the atom, so that the nuclei could capture them to form the first atom. The earliest atoms were primarily hydrogen and helium, which are still the most abundant element in the universe. Cosmology researchers have identified and astronomers have discovered still this hydrogen and helium are the abundant element in the universe. Gravitational force caused clouds of gas to join and form stars, and heavy atoms were created within the stars and sent throughout the universe when the star exploded. The star explosion is called a supernova explosion. So, according to CERN understanding, atoms and subatomic particles have started some 13.7 billion years ago. Coming to the history of atom, the first atom was proposed by Greek philosopher Democritus. Democritus introduced this atom around 450 BC. Democritus came to this concept because if we cut a piece of matter into smaller and smaller pieces, what happens to that matter? That's the question arised in the mind of Democritus. He concluded that a point would be reached if you cut a matter into smaller and smaller, where matter could not be cut into still smaller pieces. He called this uncuttable piece of matter as atomos. Atomos is the Greek term from which the term atom has born. This is where the term atom has come from. So Democritus coined the term atom. But as years go, Greek philosophers questioned the concept of Democritus. Then Greek philosopher Aristotle came. Aristotle came after 10 years of Democritus. Then Aristotle rejected Democritus' idea of atoms. Aristotle thought that all materials on earth were not made up of atoms but made up of 4 elements like earth, fire, water and air. This is the idea of Aristotle. For 2000 years, this Aristotle idea is the prevailing one among the scientists and people. Most people followed Aristotle idea, causing Democritus' idea to be overlooked for about 2000 years. Then Aristotle's view was finally proven incorrect and his teachings are not present in the modern view of the atom. After 2000 years, another scientist named Dalton brings back the term atom. Around 1800 AD, a British chemist named John Dalton revived Democritus' early ideas about the atom. The atomic theory developed by Dalton consists of 3 ideas. The first idea is all substances are made up of atoms. Atoms are the smallest particles of matter. Atoms cannot be divided into smaller particles. They also cannot be created or destroyed. That's the first idea Dalton throwed about the atom. Then the second idea is all atoms of the same element are alike and have the same mass. Then the third one is atoms join together to form compounds. A given compound always consists of the same kind of atoms in the same ratio. These are the 3 ideas put forth by Dalton in the theory of atom. Dalton's theory was soon widely accepted. Most of it is still accepted today. The only part in Dalton's theory no longer accepted is his idea that atoms are the smallest particles. Scientists now know that atoms consist of even smaller particles like proton, neutron, electron, and those proton, neutron, electron are further made up of quarks. The next major advance in the history of the atom was discovery of electron. J.J. Thomson discovered electron in the year 1897. He is a British physicist. This electron was the first subatomic particle discovered. Then after J.J. Thomson, Millikan came. Then he measured the charge of the electron. Millikan experiment is still accepted by the scientific community as the authentic experiment to find the charge of an electron. This is the next major advancement in the history of atom. Then Thomson put forth another model called plum pudding model. Thomson knew that atoms are neutral in electric charge. Thomson thought that most of the atom must be positive to cancel out the negative charge. Thomson calculated the charge to mass ratio of electron. He said that an atom is like a plum pudding which has plums scattered throughout it. That's why Thomson model of the atom is called the plum pudding model. This plum pudding model is the first model of atom in the history of atom. Then Rutherford came. Rutherford finds the nucleus. a positive charged entity very small in size exists inside the atom, and remaining space of the atom is empty. 95% of the space of the atom is empty. This is the idea put forth by Rutherford. Rutherford is a physicist from New Zealand. His full name is Ernest Rutherford. He did the next major discovery about atom. He discovered the nucleus. In the year 1911, he used alpha particles to study atoms. The scattering of alpha particle experiment is still studied widely to understand various properties of different atoms. Based on Rutherford result, Rutherford concluded that all the positive charge of an atom is concentrated in a small central area inside the atom. He called this small central area as the nucleus of the atom. This is the Rutherford gold foil experiment. He directed the alpha particle to hit the gold foil. Most of the alpha particle passed through the gold foil. Some alpha particles backscattered the gold foil, and some alpha particles deviated to a small amount in the gold foil. This is how Rutherford alpha particle scattering experiment played a vital role in the properties of atom. Rutherford later discovered that nucleus contains positively charged particles. He named the positively charged particles as protons. Rutherford also predicted the existence of neutrons inside the nucleus. However, he failed to find the neutrons. One of his students, a physicist named James Chadwick, went on to discover neutrons in the year 1932. This is how the three fundamental particles came into existence in the history of atom, in the history of science. J.J. Thomson discovered electron, Rutherford discovered proton, then Rutherford student James Chadwick discovered neutron. Rutherford discovery said that Thomson plum pudding model was incorrect. According to Thomson's plum pudding model, the positive charge is spread throughout the atom. But Rutherford says that this positive charge is not spread out everywhere in an atom. It's all concentrated in a tiny part inside the atom, which is called nucleus. The rest of the atom is empty space, except for the electrons moving randomly through it. The rest of the space in atom are covered by electrons. In Rutherford model, electrons move around the nucleus in random orbits. He compared them to planet orbiting the sun, planets orbiting a star. That's why Rutherford model is also called planetary model. The next breakthrough in the history of atom is Bohr model. The Bohr model shows that atom has a small positively charged nucleus surrounded by orbiting electrons. A stylized representation of a lithium atom illustrates Niels Bohr's atomic model that an atom is a small positively charged nucleus surrounded by orbiting electrons. Bohr said that those electrons are non-radiating orbits. He put forth this concept to overcome the question called, if a charged particle is moving in a circular orbit, it will emit radiation. Once it emits radiation, its energy will go off, then automatically that charged particle will die and fall into the nucleus. This was the question put forth by many scientists. So Rutherford argued that the electrons are not revolving in a radiating orbit, it's revolving in a non-radiating orbit. So when it's moving in a non-radiating orbit, it will not radiate, so its energy is preserved. It will keep on revolve in that orbit. This is the idea Bohr said for the questions put forth by the scientist about the radiating orbit. Then the next powerful concept discovered in the history of atom is Edwin Schrödinger. Schrödinger equation in quantum mechanics is very famous, which connects the de Broglie matter waves and particle nature of atom, any entity in science. So a powerful model of the atom was developed by Erwin Schrödinger in the year 1926. Schrödinger combined the equations for the behavior of waves with the de Broglie equation to generate a mathematical model for the distribution of electrons in an atom. So using Schrödinger equation, we can find the energy of an electron, energy of many electrons, then energy of an atom, so that the wave nature of an atom can be calculated mathematically using the concept of Schrödinger, Erwin Schrödinger. This is the history of atoms. The first atom was put forth by J.J. Thomson, then the Bohr model, modern Bohr model, then Rutherford model, then Erwin Schrödinger model, then vector model, then Sommerfeld model. Like that, many models were introduced in the models of atom in the current science. Coming to the structure of atom consists of three basic particles: protons, electrons and neutrons. The protons and neutrons are inside the nucleus. The center part of the atom is called as nucleus. The center part of the atom is called positively charged part, and neutrons have no charge. So the center part of the atom has only positive charge, neutrons will not have charge. The outermost regions of the atom are called electrons, electron shells, and these electron shells contain the electrons which is negatively charged. Atoms have different properties based on the arrangement and number of their basic particles. If you take hydrogen, it has one proton and one electron. Then if you take carbon, it has carbon 12. It has 12 number of electrons and 12 number of protons. So like that, based on the number of basic particles, atoms have different properties. This is the structure of atom. Here you could see two positive charged protons and two neutrons. That part is called as nucleus, and this is electrons. The outermost part is electrons. Atoms combine to form molecules, which then interact to form solids, gases or liquids. Example for molecule is water molecule, then sodium chloride, then sodium hydroxide. Like that, in solid state physics, in solid state chemistry, in general solid state science, many molecules are there. Those molecules combines together to form solids, and gases can also be formed. Liquid can also be formed using these molecules. Coming to the mass of proton and neutron. The mass of proton and neutron are approximately same. It is about 1.67 into 10 power minus 24 grams. That is the mass of proton. Scientists define this amount of mass as 1 atomic mass unit or 1 Dalton, because after 2000 years, Dalton bring back the term atom proposed by Democritus during the year 450 BC. Although similar in mass, protons are positively charged while neutrons have no charge. Therefore, the number of neutrons in an atom contributes significantly to its mass but not to the charge. James Chadwick discovered the neutrons. These neutrons contributes significantly to the mass of the atom but not to the charge of the atom. Electrons are much smaller in mass than protons. These electrons are the first subatomic particle discovered. The weight of one electron is 9.1 into 10 power minus 28 grams, or about 1 by 1800 of an atomic mass unit. One atomic mass unit is the mass of a proton or neutron, which is 1.67 into 10 power minus 24 gram. Here the mass of electron is 1 by 1800 of atomic mass unit. Therefore, these electrons do not contribute much to an element's overall atomic mass. When considering atomic mass, it is customary to ignore the mass of any electrons and calculate the atomic mass based on the number of protons and number of neutrons alone. So, these electrons do not contribute much to the mass of the atom. Electrons contribute greatly to the atom's charge, as each electron has a negative charge equal to the positive charge of a proton. That's why in a neutral atom, the number of electrons orbiting the nucleus is equal to number of protons inside the nucleus. If one electron deficiency is there in an atom, then that atom is called as a positive ion. An excess electron is there in an atom, then that atom is called negative ion. So, ionization of atom will happen based on the attachment or detachment of electron from an atom. Volume of atoms. It is assumed that it is taken that atoms are in spherical shape. Accounting for the size of protons, neutrons and electrons, most of the volume of an atom is empty space. That is, 99% of the space of the atom is empty. Atoms are denoted by two numbers, atomic number and mass number. Atomic number says the number of protons and number of electrons present in an atom. Neutral atoms of an element contains an equal number of protons and equal number of electrons. Number of protons determines an element's atomic number denoted by Z and distinguishes one element from another. Today in our universe, 118 elements are identified, discovered by chemists, scientists. So, here if you take carbon atomic number is 6 because it has 6 protons. Carbon 12, its mass number is 12. So, from that mass number you can get the number of electrons and the number of protons. So, atomic number of an element of an atom is important to understand the number of protons and number of electrons existing in an atom. Coming to mass number, an element's mass number is the sum of number of protons and number of neutrons. The small contribution of mass from electron is disregarded in calculating the mass number. This approximation of mass can be used to easily calculate how many neutrons an element has by simply subtracting the number of protons from the mass number. Protons and neutrons both weigh about 1 atomic mass unit. We know that, already I have said that. Electron mass is 9.1 into 10 power minus 31 kilogram. Mass of a proton is 1800 times greater than the mass of electron. So, mass number contributes to the understanding of number of protons and number of neutrons present in an atom. Coming to the isotopes of an atom, isotopes of the same element will have same atomic number but different mass number. In universe, many elements are existing like this. If you take carbon 12 is there, carbon 13 is there, same atomic number but different mass number. Scientists determine the atomic mass by calculating the mean of the mass number for its naturally occurring isotopes. If you surf through the chemistry's website, you can understand how many isotopes are there for each element present in the periodic table. These isotopes are used to calculate, to measure the atomic mass of an atom. Often the resulting number contains a decimal. For example, the atomic mass of chlorine is 35.45 atomic mass unit, because chlorine is composed of several isotopes, some within an atomic mass of 35 AMU, 17 protons and 18 neutrons, and some with an atomic mass of 37 AMU, atomic mass unit, 17 protons and 20 neutrons. So like that, isotopes of an element is used to calculate the atomic mass of an atom. Coming to atomic models. Most prominent atomic models used today are J.J. Thomson atom model, Rutherford atom model, Niels Bohr atom model, Sommerfeld atom model, vector atom model. J.J. Thomson atom model is also called as plum pudding atom model. Positive charge is spread throughout the atom and electrons are embedded on the positive charge. This is the concept, this is the idea put forth by J.J. Thomson. J.J. Thomson discovered electron. Later, Rutherford's advancement in atomic model cancelled the J.J. Thomson atom model. Then Rutherford atom model gave the idea of nucleus, a tiny part whose mass is the mass of an atom, whose mass is at the center, is put forth by Rutherford. Then Niels Bohr came. Niels Bohr atom model said that electrons are revolving around the nucleus in orbits. Those orbits are non-radiating orbits. Then Sommerfeld atom model came. Sommerfeld atom model gives gives concepts like angular momentum quantum number and magnetic momentum quantum number. So quantum number concepts are advanced by Sommerfeld atom model. Then vector atom model came. In vector atom model, directions of this angular momentum and total magnetic momentum, all these things are included in vector atom model. So these atom models are in current use in the understanding of atom models. So in this lecture we learned the term atom. This term atom comes from the Greek word indivisible. According to CERN laboratory, which is a pioneer in particle physics, atoms were created after the Big Bang explosion, which happened some 13.7 billion years ago. The history of the atom begins around 450 BC with a Greek philosopher named Democritus. Then Aristotle thought that all the materials on earth were not made up of atoms but of the four elements earth, fire, water and air. Around 1800, a British chemist John Dalton revived Democritus' early idea about the atom. Discovery of electrons were the first subatomic particles discovery in the year 1897 by a British physicist named J.J. Thomson. J.J. Thomson atom model is called as plum pudding atom model. Then Rutherford finds the nucleus. Rutherford atom model came. Then number of protons determines an element's atomic number and distinguishes one element from another. An element's mass number is the sum of number of protons and number of neutrons. Isotopes of an element are used to calculate the atomic mass of an element. Then atom models were there. You learnt about the atom models: J.J. Thomson atom model, Rutherford atom model, Bohr atom model, then Sommerfeld atom model, vector atom model. these are the ideas you learnt from this lecture. You can learn more things about atom by surfing through these websites. Thank you.